So far, we've covered topics related to APIs, such as API, REST API, SOAP, and GraphQL. In this video, we'll look at gRPC, our fifth topic. gRPC is an RPC framework created by Google. First, it's necessary to know what RPC is. RPC stands for Remote Procedure Call. As you can tell from the name, it's a protocol that allows you to run a function on another computer as if it was your own. Here is a sample code of a program that uses an RPC called XML RPC. RPC is language independent, so it can be used between servers and clients that use different programming languages. In this example, the server was written in Ruby and the client in C#. The client sends a message to the server requesting to perform a function, which adds the two given numbers. This function, named add, is declared and defined on the server. But if you look at the client's code, you can see it calling this function as if using its own function. Not all RPC codes are like this, but this code is an example that shows important features of RPC. Normally, this object called a stub plays a role like a peer puppet on a server. You can see that the add method is being called from this stub object. Something that you ask this peer puppet on your computer is just like asking the remote server. Because of these features, developers don't need to know or consider each server or communication process, but they can focus only on using the functions as if they were using local functions according to their needs. gRPC is one of many RPC frameworks. With high performance, a strong developer community, and abundant tools and libraries, gRPC has established itself as the most widely used RPC today. Now, let's compare the important features of gRPC with the RESTful API. I'll use the book rental service example that we've been using since the REST API video. So far, we've only been dealing with the communication process between the client and the server. Nowadays, many services set up their server through the connections of various microservices. In the case of the book rental services server, it can be composed of microservices such as book management, user management, loan and returns, review management, search, notification, etc. Of course, for the service to operate, there is a need for constant communication between these microservices through requests and responses. I'll use gRPC for the communication taking place between the book information management service and the loan service. Here, the book information management service on the left becomes the client, and the loan service on the right becomes the server. If the client sends a request to the server to check the availability of the book for rental with the index number and quantity as parameters, the server responds with availability, book location, rental price and deadline, and additional information. You learned that RESTful API uses JSON. JSON is noticeably more concise than the XML used in SOAP, but if the same types of requests are repeated often, there arises a need to shave off the repeating parts. This would be the key parts. As these requests and responses are exchanged more frequently, the portion wasted due to this duplication will also grow. But if we eliminate this key, how can we distinguish what each value represents? gRPC uses something called protocol buffer for this. Let's examine this file with a .proto extension. The keys we just saw in the JSON object are written as fields like this, and you can see that each has a number attached like this. This .proto file is a promise about how each message will be written, and it's shared with both the server and the client. The client and server write and pass messages based on this standard. Additionally, make sure to note the checkbook availability function, which specifies the two data below as parameters and return values. This will be a function that is implemented on the server and called from the client. Now, let's examine the server and client codes one by one. The server code on the left is written in Python. The client program on the right is written in Java. The checkbook availability we have just seen in the .proto file is defined as a function on the server, and you can see it being called on the client via a stub object. The book request class and the book response class used as parameters of the request and return values of the response. And these classes used as stubs are all auto-generated based on the .proto file. Like this, you can use the protocol buffers to smoothly communicate between parties with different languages and environments based on agreed specifications. Protocol buffer doesn't just simplify the keys of messages, but serializes them into binary forms for transmission. For those who don't understand what this means, you can think of it as sending a message in a compressed form. This means it can transmit at much faster speeds than text-based methods such as JSON due to its smaller size. Therefore, gRPC can exchange requests and responses more efficiently compared to other methods like REST API. Another strength of gRPC is that it is based on HTTP2. I will cover HTTP and its versions in detail in a future video on that topic. For now, let me explain it with a simple analogy in this video. HTTP 1.1, commonly used in RESTful APIs, is like sending requests and responses through letters. If a client sends letters, the server receives and responds to them one at a time in a sequential manner. If the processing of the first letter sent is delayed, the letters that follow have to wait until the previous letter is processed. On the other hand, HTTP2 is like having a conversation over the phone. Once a call is connected, the server and client can communicate simultaneously in both directions. You can send multiple messages at once and quickly process and respond to them out of order. They can also send messages to each other at the same time, and the server can proactively send messages independently of the client's requests. Binary data exchanged in gRPC is also more efficiently handled by HTTP2. Therefore, in gRPC, server and client can communicate more quickly and diversely. When I release videos about HTTP later, I will add a card to this segment. Lastly, gRPC encrypts data transmission via TLS. To explain this concept simply and briefly, it's about preventing anyone from spying on the message, changing the content of the message, or impersonate a client or server. In this way, through TLS, gRPC ensures secure communication where important data comes and goes.
There seem to be a lot of topics to cover in the future.
Yes, based on the features we've looked at so far, let's wrap up this video by figuring out where gRPC is suitable for use. First of all, gRPC is hardly used in web front ends that operate in browsers yet. Although most mainstream browsers support HTTP2 today, they still lack support for the detailed features of HTTP2 required by gRPC. It can be used through a technology called gRPC Web, but there are things to be set up, like proxies. The place where gRPC is most widely used is in microservice architecture. The strengths of gRPC, such as fast transmission, high performance, language neutrality, and bidirectional streaming, are important factors in communication between microservices. It's very useful in areas such as e-commerce platforms, banking and financial services, medical record systems, IoT and device management, where gRPC is extensively utilized. You can apply gRPC where real-time interaction and synchronization with servers are needed, such as in mobile applications or online games. If you visit grpc.io, you can check which languages can use gRPC and how to implement gRPC in each language through the guides on each page. Today, we learned about gRPC like this. In the next video, we will discuss WebSocket. Then, see you in the next video.